So let's talk about this front side of the paper. We're looking at this quadratic. We're looking at this parabola, right? Where is the axis of symmetry for this parabola? What does the axis of symmetry mean?
It means it goes through the vertex.
It means it's a line that goes through the vertex. Good. It's where I could fold my parabola in half, right? Just folding my parabola in half. So it's this line right here. And what is the equation of this line? That's for vertical lines, it's just x equals a number. But this specifically is x equals -3. So when I ask you to identify the axis of symmetry, I'm looking for an equation. I'm not looking for the vertex. I'm not looking for a point. I'm not looking for just a number. I'm looking for an equation. X equals whatever that number is. Does that make sense? Okay. Okay, what about the x-intercepts? What does it mean to be an x-intercept? Yeah, where the line intersects the x-axis. And where is that at in this parabola? Perfect, -1 and -5. And remember, these are points. We denote points by writing ordered pairs. What's my first ordered pair of an x-intercept? -1, 0, and -5, 0. Good, right? The y value of my x-intercept is always 0. Okay, and then what do you notice about the No, you could write -5, 0, -1, 0. That doesn't matter. But you can't write 0, -1, 0, -5. That's no. Okay. What do you notice about the location of those x-intercepts compared to the axis of symmetry? Yeah, they're the same distance away. Do you guys know another word that means same distance?
Symmetrical.
No, it's related to symmetrical, but no. Equidistant or equidistant. So these points are equidistant from the axis of symmetry. They're equally distant from that center line. Okay, let's look at this. For which x values is f of x equal to 5? Remember, f of x is just like saying y. So where on the graph do we have a y coordinate of 5? 0, that's this point right here. Where else? And -6, exactly. Okay, so when x is 0 and when x equals -6. And again, what do you notice about those relationships? The relationship between the distance. Yes, that's what we're trying to say, right? Those points are equidistant, again, from the axis of symmetry, equidistant. Good. Okay. Right. So kind of the main idea that we have here is that parabolas are symmetrical. So across the axis of symmetry, I have mirroring points that reflect one another, right? And those points that are equidistant from the axis of symmetry, points equidistant, have the same y value. Okay, right? These 2 points, are 2 away from the axis of symmetry. They have the same y value of 0. These 2 points are 3 away from the axis of symmetry. They have the same y value of 5. And if we look down here, this one is 1 place away from the axis of symmetry. They have the same y value of -3. So it's always mirroring each other all the way out. Okay? So if f of 4 is 45, what's the mirroring point? What's the other input? What's the other x value that would give me an output of 45?
-4?
Not -4. Remember, they have to be equidistant from the axis of symmetry. So think about -4 is like over here, or +4 is over here, right? This is saying this f of 4, that's my x value. So how far away from the axis of symmetry is 4? 7, right? I have to add 7 to get to 4 over here. So then what would be, where would the equidistant point be on this side? -10, right? So I start at -3 and I go this way. So I'm subtracting another 7, right? Does that make sense? So 4, f of 4 means I'm looking at, like, let me just give you another example of one that we can actually see. F of -1 is 0. The output, if the input is -1, my output is 0. This is telling me if my input is 4, my output is 45, which is like way up there. But that means I'm going to have a mirroring point over on this side. And those 2 mirror points have to be equidistant from the axis of symmetry. So if this point has an x-coordinate of 4, it's 7 spots away from the axis of symmetry. So the mirroring point on this side has to be 7 points in the opposite direction. Does that make a little more sense? Okay. So I just take -3 minus 7, and that's going to get me -10. So that's my other x value. -3, whoops.
Will that be on the quiz?
There's stuff like that on the quiz. -3 plus 7 gave me 4. So -3 minus 7 gives me -10. Okay. All right, and then number 4. So I have a vertex at 2, 5. My vertex is at 2, 5, right here. And the parabola passes through the point -4 or 5, -4. 5, -4 right here. Does this parabola open up or down?
Yeah.
Why do you say that?
Because the vertex is at the top and the tips is at the bottom.
Yeah, so this point, the given point, is below the vertex, which means that it has to be like this. The vertex is my maximum, so this parabola opens down. Down. Okay, and I'm going to draw this half of the parabola. But remember, our parabolas are symmetrical across the axis of symmetry. My axis of symmetry goes through my vertex. So my axis of symmetry goes through what number? 2, right? So that equation is x equals 2. Okay, so how could we figure out another point that is on the parabola?
You could put a dot in the same amount of spaces on the other side of the line of symmetry.
Not from the vertex though, right? Because the vertex is the only point that doesn't have a mirror point. Yeah, but this point down here, this 5, -4, has a mirror point. And how far away is this point from the axis of symmetry? 3. So that means I'm going to have a mirror point 3 the other way. So right over here. And what is it? What are the coordinates of this point? -1, -4. Perfect. Okay. So now I can kind of draw the rest of my parabola. It's a little wonky, but that's okay. Okay, so I have an x-intercept at 4.236. 4.236, that's like right around there, right? I have an x-intercept there. How am I going to figure out my other x-intercept? I can kind of see it on my graph. I know it's somewhere between 0 and -1, but what is it? How am I going to figure it out? How'd you get there? Why do you say that? Yeah, it's that same idea, right? This x, so the axis of symmetry is halfway between my x-intercepts. This x-intercept is equidistant from the axis of symmetry to this one. So what's the difference between 4.236 and 2? What's the difference? What's 4.236 minus 2? Good, 2.236. So that's this distance, right? The distance is 2.236, right? I added 2.236 to 2 to get to that 4.236. So what do I need to do to get to this x-intercept? 2 minus this, right? No, it is negative. It's 2 minus 2.236, which would give us what? Bless you. Yeah, negative 0.236. So again, every point on the parabola besides the vertex is going to have those mirroring points. Mirroring points. And mirror points have the same y value, and their x values are equidistant from the axis of symmetry. Okay? It's kind of a lot of like vocab, it's kind of wordy, but I think when you see the picture, you can see it. It's just a mirror image of each other on either side, right? If you started graphing a parabola and one side looks like this and then your other side starts looking like this, you know you're doing something wrong, right? They have to be mirror images of each other. Let's go to the other side. Go away. Go to the other side, we'll take some notes. So parabolas are symmetric across the axis of symmetry. Parabolas are symmetric across the axis of symmetry. And that axis of symmetry is halfway between our y or our x-intercepts, between the x-intercepts. Axis of symmetry is halfway between the x-intercepts. And our points that are equidistant from the axis of symmetry have the same y value. Okay, let's draw a little picture of that. Okay, there's my coordinate plane. And then I have a parabola that might look like this, right? What is this point called on the parabola? The vertex. And what is this line called that goes through the vertex? Yeah, line of symmetry or axis of symmetry, right? And what we're kind of like discovering today is that, first of all, our x-intercepts are equidistant from the axis of symmetry. The axis of symmetry is right in between the x-intercepts, even though it doesn't really look like that on my picture. And also, any point on the parabola has a mirror point. Those mirror points have the same y value. They have like the same height. So they'll be equidistant from the axis of symmetry, and they will have the same output, the same y value. Right, this distance is the same as this distance. Cool? 3 more little things. Axis of symmetry goes through the vertex, always. Parabolas that open up, meaning they look like this, have a vertex. I don't want to say it like that. That's parabolas that open up. Vertex is a minimum or a maximum? Yeah, the minimum. Right? If my parabola opens up, my vertex is at the bottom, so it's a minimum. And then the opposite is also true. Parabolas that open down yeah, vertex is the maximum. Right? They look like that. That vertex point is at the top, so we call it a maximum. Cool? Yes.